So welcome to today's GATE video. Good morning everyone. I am Ms.O.VASANTHAKUMARI working as an assistant professor in the Department of Computer Science and Engineering at SA Engineering College. Today I am going to explain graphs in data structures, right? So graph is very important concept in computer science. We use graph in real life like social networks and Google Maps. Now let us start. Let us discuss one by one. So first one is components of a graph. So graph has two main parts. First one is vertices and second one is edges. Vertices is nothing but that is the vertices are also known as node or vertex, and each node can be labeled or unlabeled. Next component is edges. Edges are used to connect two nodes of the graph, and it can be ordered pair of nodes in a directed graph, right? So edges can connect any two nodes in any possible ways. So here there are no rules, and sometimes edges are also known as arc. Edge connect two node in any possible ways. So without edge we cannot connect the nodes. So next one is a graph is a non-linear data structures. That means elements are not stored in the sequential order. So we will see example of the graph. So here how many nodes are here? 5 is one of the node, 3 is one of the node, 1 is one of the node, and 2 is one of the node, 4 is one of the node, and 6 is one of the node. Here are which each node can connect the other node using edges, right? So edge connect between two nodes, right? So next one is types of graphs in data structures. Actually a graph are divided into different types. First one is we will see the types based on weight and directions. First one is weighted graph. So a weighted graph is a graph where each edge has a number that represents distance or cost or time. That means so weighted graph is nothing but edges have a value, right? Edges have a value. So this value can be distance, cost or time. So let us see one example. So here V9 is one of the node and V1 is one of the node. Here distance between two nodes, for example, distance between two nodes is 10 kilometers, right? So and also weighted graph helps to find the shortest path. So next one is unweighted graph. So unweighted graph is nothing but edges do not have any value. So that is the unweighted graph. So an unweighted graph is a graph where all edges are treated equally with no extra value like distance. So let us see one graph. Actually this is the unweighted graph. Here all edges are equal, and this unweighted graph edges do not have any values, and it only shows like connections. Next one, based on edge directions, we will discuss about undirected graph and directed graph. So undirected graph is nothing but in a graph in which edges do not have any directions. That is, the nodes are unordered pair in the definitions of every edges. So undirected graph is nothing but edges do not have any directions. Suppose if A can go to B and B is also go to A. For example, social friendship. For example, friendship. Next one is directed graph. So directed graph, a graph in which edge has directions, that is the nodes are ordered pair in the definitions of every edges. So let us see examples of undirected graph and directed graph. So this is the directed graph. So a directed graph, edges has the directions. Here 5 node will visit to the third node, and this is the undirected graph. So undirected graph, edges has no directions, right? So one best example is undirected graph is friendship, and directed graph A can, suppose A can go to B, but B may not go to A. So next we will see the representations of the graph in data structures. So here how to store the graph in computer science. There are two methods. First one is adjacency matrix, second one is adjacency list. So adjacency matrix is nothing but this method uses a table, all rows and columns are vertices, right? So in this method, the graph is stored in the form of 2D matrix where rows and columns denote vertices, and each entry in the matrix represents the weight of the edges between those matrices. And so this is an example of adjacency matrix of graph. Let us take one graph. 0, how many nodes are here? 0, 1, 2, 3. Here you have to represent rows and columns. You have to form first table. So in this table you have to represent rows and columns or vertices, right? So here 0 to 0 means if there is a connection means we write 0. We write 1. If there is no connections, we write 0. So here you have to see 0 to 0, that is 0, because if there is no connection here, and 0 to 1 means if there is a connection, so we write 1, and next 0 to 2, if there is a connection, so we write 1, again 0 to 3, here if there is no connection, so we write 0. So like this you have to represent all the rows and columns. So next, adjacency list representations of the graph. So in adjacency matrix of the graph, one more advantages is here, easy to understand, and we will use more memory space. We will use more memory space, and more memory space is required. So next one is adjacency list representations of graph. So adjacency list representations means it stores its neighbor node. That means the graph is represented as a collections of array list. So there is an array of pointer which points to the edges connected to the vertices. So let us see one example. Here 0, if node 0 can connect 1 and 2, if node 1 can connect 0 and 2, and if node 2 can connect 0 and 3, if node 3 can connect 2 node only, because there is no edge between 3 and 1. So this is the representations of adjacency list. And actually this it saves, it require only less memory space, okay, and less memory space. So most of the graph, actually this adjacency list can use, we have to represent large graph. So next concept is DFS. DFS means depth first search. It goes deeply first. First we will visit node 1. Again it will visit other neighbor nodes. Again we come back, again we will find the answer, right? That means it's going like inside a tunnel. So in DFS for a graph, we traverse all adjacent vertices one by one. When we traverse on adjacency vertex, we completely finish the travel of all vertices reachable through that adjacency vertex. And this is similar to pre-order traversals of binary tree. So this is the examples of DFS. So let us take first node 0, and 0 can visit first node, that is 1. Again 1 will visit to second node, and 2 will visit to third node. Again third node, here there is no direction, so again it will go to the it will go to the second node, because in here backtracking method is used. Again second node will visit to the fourth node. So here final answer is 0, 1, 2, 3 and 4. So this is the output of the previous graph, that is 0, 1, 2, 3, 4. So this is explanations of DFS graph. So the source vertex is 0 and we visit it first, then we visit its adjacent node. So we will start at 0 and it mark as visited, print 0, and we will move to 1 and mark as visited, and again we will print 1. So like this you have to find the answer of DFS. So final answer is 0, 1, 2, 3, 4. Next concept is BFS. So BFS means it goes level by level. It goes level by level. Like so BFS is a graph traversal algorithm that starts from a source node and explore the graph level by level. First it visits all the nodes directly adjacent to the nodes, then it moves on to the visit the adjacent nodes of those nodes, and this process continue until all reachable nodes are visited. So BFS is different from DFS, because DFS it goes deeply, it's going like inside a tunnel, and BFS means it goes level by level. So that is the main difference. So let us see one example. So here example of the BFS graph. First let us take the node 0. The 0 can go to 2 and 2 can go to 1, again can go to 3, again it can go to 4 and 5. So the final answer is 0, 2, 3, 1, 4 and 5. So this is the explanations of the BFS graph. So now let us discuss previous year GATE questions. So these questions asked in the year of 2022, and then first question is, consider the tree arc of BFS travel from a source node W in an unweighted graph, connected undirected graph. The tree T formed by the tree arc is a data structure for computing. The question is about BFS. So BFS means find the shortest path from source node to all other nodes. So the correct answer is that is the B answer, the shortest path W to every vertex in the graph. So second one is, which of the true traversals BFS and DFS may be used to find if there is a path from S to T given two vertices in a graph S and T. To find path, first to find path between two nodes, we can use both DFS and BFS, because DFS is nothing but depth first search. So that means it goes deeply. It goes deeply. Next, BFS means breadth first search. It goes level by level. So we can use both DFS and BFS. The correct answer is C, that is both BFS and DFS. So the next question is, which of the conditions written below is sufficient to detect a cycle in a graph? The question is to detect a cycle in a directed graph. So the answer is there is an edge from the currently visitor node to an ancestor of the currently visitor node in the forest of DFS node, because the DFS means the depth first search. It goes deeply. Okay, so the correct answer is B. So the next one is, the breadth first algorithm has been implemented with the help of a queue. What is a possible order of visiting the nodes of the following graph? So here already they given one graph. So here you can start queue. Again this node can visit the M, and this node can visit the N, and this node can visit the P, and this node can visit the R, and this node can visit the O. So the final answer is Q, M, N, P, R, O. That means BFS means to find the shortest path from source node to all other nodes. So the correct answer is C. So next one is, a connected planar graph having 6 vertices and 7 edges contains, so how many regions? Actually we will find the planar graph. To use the formula. So V minus H plus F is equal to 2. So this is the formula to find the planar graph. So how many vertices are here? 6. And how many edges are here? 7. Plus F is equal to 2. Here F is equal to 6 minus 1 minus 1. So minus 1 plus is equal to 2. F is equal to 2 plus 1. So F is equal to 3. The correct answer is 3. So thank you. Continue to next video.